Hi, got another teardown for you, and you know we love vintage computers / calculators here on the EEVblog. Got a Bobby Dazzler, look at this thing. It's the Canon Canola SX100, straight out of the early 1970s. I don't know a huge amount about this. It's a bit hard to find information, don't have a manual for it. I do have a manual and a service manual for the later SX300, which dates from 1975. So I assume the SX100 is the model like either one or two generations previous to that, but I did get a date of this of 1976. So I'm not sure how accurate that date is because, for example, the famous HP 35, the first pocket calculator, came out in 1972, and then 1974 had the HP 65 programmable pocket calculator, and this thing, which weighs an absolute ton, what is it, 10 kilos or something, and is an absolute beast. Sure, it's got a printer and everything else, but this is actually a programmable calculator, not really a computer. As such, I believe it's only got like a few dozen memory registers and stuff like that, but it is fully programmable and you can execute programs and stuff on it. So programmable calculator, thermal printer, everything else. So I thought we'd check it out. This could make for an interesting teardown. Fantastic. Still in pretty good nick by the looks of it, and got a full roll of paper too. Beauty. So if you used one of these things, let us know down in the comments or over on the EEVblog forum, because, well, this is quite an unusual beast for like the early 70s. As I said, those pocket calculators, started coming around from 1972 onwards. So you got to question the value of something like this in like 74. As I said, the 1975, I believe, is the date for the SX300, which is basically, it looks identical to this. It might have some extra performance or features or something like that, but it looks near identical to the SX100 that we've got here. So yeah, this huge, big desktop beast of a thing, which weighs a ton, and, I don't know how it would compare with the HP 65, for example, from 1974, but that could fit in your pocket. This thing, I don't know, have a hard time. So was this thing just too late to the party? Did it miss the pocket revolution? I don't know. When was Canon's first pocket calculator? Did they get into pocket calculators? I think they did eventually. But yeah, did this one miss the boat? I don't know. Anyway, let's tear it down, see what makes this thing tick. So check it out. It is actually pretty sexy looking. I mean, I actually do like the keyboard layout, which is quite nice. You've got your trig and scientific functions over here. You've got your regular keypad, exponents up here, change sign, nice big 0 key. I don't know what the start and presumably start program or whatever. Got some additional functions over here, your parentheses, or we've got a dedicated inverse key, fantastic. And then it looks like you've got some of the programming keys over here, and then a whole bunch of interesting looking stuff up the top, and some sort of recorder. I don't know what that is. We've got, debug and programs and step backs, insert, delete programs. And we've got our degrees, radians, gradients, all that sort of stuff. And then we've got how it rounds. Does it always round down? Does it always round up? Or does it do the 5-4 thing? Fantastic. And then what looks like our fixed number of decimal points. So F would be floating point, I'm going to assume, and then no decimal points, 1 through to 6, something like that. Anyway, does have a rather interesting layout. No, I don't mind it at all. I think it's pretty nice. And on the back of this beast, we've got a weird ass mains connector. Don't know what that one is offhand. We've got two, unfortunately we've lost the backing plate on this thing, and two things which there doesn't seem to be connectors on the back there. So I'm not sure what they're actually for. Maybe some sort of expansion thing, but there's no mating internal connectors by the looks of it. Then what looks like a 48 column to 24 column selector here for the paper. Presumably we've got a full roll of paper in there, and beauty. All the best stuff's made in Japan, and this is the fancy pantsy non-interference model. Anyway, let's crack this thing open. I'm going to assume that the feet aren't part of the thing, and these screws around here will hold on the top part, and the top part should just lift straight off. That'd be very nice. We should get a good look at the innards. All right, let's try and lift it. Of course, I expect all this, early 70s. Who knows when they started designing this thing. By the way, if you've got an accurate date when this thing was released, please let us know in the comments. Anyway, I'd expect all dip construction. It's probably, will it use an actual processor, or will it use a discrete logic processor and stuff like that? I don't know. It's big and heavy enough to sort of have enough chips to have its own, to roll its own processor. So hello. Oh, is that? Yeah. Oh, there's a few wiring harnesses. Oh, they got a decent length on that. Look at that. There you go. Yep. No, looks like we've got some sort of processor. That's certainly not all discrete. That's for sure. Oh, I got some, look at all the ham wiring. Oh, look at this. So we got some diode logic down there by the looks of it. And, geez, that's all pretty how you doing, isn't it? That's terrible, Muriel. But, not uncommon for the era, though. But, they've sort of like cable-tied stuff. Lots of bodges. Wow, look at this. Wow, none of this 0.1 inch header and ribbon cable rubbish. Nope. Card edge, and each one of them individually heat shrunk and soldered. I do like how they've formed the metalwork up here to keep the connector in. That's rather nice, so it can't fall out. That's pretty good. But it kind of all sort of fell apart up here when they went, oh, bugger that connector rubbish. We can just hand solder those puppies on. Thank you very much. Oh, check out these poor old trannies here over on one side. They're like falling over, staggering off to one side. No one took pride in keeping those straight when they soldered them in, that's for sure. But you've got a diode bodge on here and resistor just sort of standing up. Those diodes, I don't know if they're a bodge or they're, there's no traces on the top. So have they drilled through the board and added those diodes? Have we got a diode gate there or something? Anyway, this cap seam here seems to be bodged on, and HD 3541. Gonna have to go Google that one. Well, either my Google foo is off, or I can't find any info on that. If I can, I'll link it in. But anyway, we've got a HD 3541, which looks like some sort of processor. Then the HD 3542, then the HD 3543. So obviously, these are SRAMs here. 3542, I'm not sure what that'd be doing. It's probably not a ROM. It wouldn't be a masked ROM. I don't know. I have to take the rest of it open. But anyway, we've obviously got some sort of Hitachi chipset. Okay, one of the oldest ones I can find is 39th week 74. So this is getting close to being, a 1975 model. So, as I said, it's, how competitive was this in... There's more bodges up there. Love it. How can big ground strap going off somewhere, buggering off to, is that going off to the printer or whatever? Ooh, flat flex ribbon, fancy pantsy. How competitive was this thing in 1975? Yeah, sure, it's got a printer and everything else, and it's kind of, it's got some programmable functionality, and it may, a lot of people will prefer a desk model over a pocket one and stuff like that, but yeah, I don't know. You want to have some good advantages. So, maybe for, scientific engineering teams, something like that, who wanted a paper trail and stuff like that, because that, it's often that's vital, so that you can, that's why a lot of accountants will still use the old, the paper tape thing as they add their, if you're bringing your shoebox worth of receipts and then they sit there and add them all up, then they've got a paper tape trail of, the actual stuff that they entered in, so they can go back and check it. So it would have been valuable from that point of view, but geez, as a general purpose scientific, calculator on your desk, you wouldn't bother wasting your desk space. So how quickly did something like this go obsolete, I wonder? So generally I'm quite surprised by this. This has like less stuff in it than I was expecting. It looks like it kind of reminds me of like a 1970s vintage PC, something like that, or like an early 80s vintage PC. Like with the like the looks like the processor, the RAM, and everything else. A couple of discrete jelly bean glue logic and all the other stuff, but. Yeah, I was just like, I don't know, I expected like the big weight of it. Maybe I was hoping that there were, lots of big cards in there with lots of like a discrete processor and, a ton of stuff. And nope, looks like it's just a micro and something else. Granted, I haven't gotten all the way under there, but I don't think this card extends too far back under here. So all the weight comes from like the 3 layers of metalwork it's got here. It's all big, thick, heavy stuff. So yeah, that's why it weighs a ton. If we lift off the printer and storage mechanism, we get this board under here. It's all just, 7.4 series logic. Nothing really much doing there. I love, though, the green jumper wires. Look, joining these, is that power? Yeah, that's ground. It's going to be joining the grounds like this. Like they couldn't get that on the board. Like they couldn't get that on the layout? Doesn't make sense. Anyway, I believe that this is the, based on where the wiring's buggering off to, this is the controller for this mysterious tape drive storage mechanism thingy. So this is like really interesting. It's not a tape drive and it's not a cartridge system. This is a head, okay? You can tell because it's got these coaxes going off here. So this is like a read-write head, and it's like it can't, like there's no loop tape or anything like that to do it. So I think it's just like a magnetic stripe card kind of thing, which wasn't that uncommon back in the day. HP used some like magnetic swipe cards for storage. I mean, it doesn't store a lot. It only needs to store like 100, like, I don't know, dozens of bytes, maybe a few hundred bytes or something like that. So you can easily store it on like a strip, like a little credit card kind of thing. And that's what it looks like it is. And yep, sure enough, you can see that down in there. Look, there's a roll. Oh, that roll. Oh, I shouldn't have touched it. That roller's gone. I was going to say, yep. That almost looks like a cork, kind of. That is weird. Anyway, that was a roller. Oops. And then we've got a micro switch there. That this one's actually a detection for the bottom. So we've got 2 slots here. Focus, you bastard. All right. So these rollers down here push against the magnetic head up here. It looks like this. Like, I don't know. It's just disintegrating. Sorry, I'm not putting any force on that. It would. So I didn't destroy it. It just had stood no chance of working at all. Anyway, so we've got the gear chain for all that to actually drive that shaft in there. That drives that. Not sure what's doing down the bottom though. Got a micro switch. There doesn't seem to be a... Oh, okay. No, I know what happens. Oh, yes. It's obvious. People are probably screaming at me. It's a paper thing. You put it in the top, it pulls it through and shoots it out the bottom, or vice versa. Maybe it, yeah. By the way, that it can't go in here and come out here because it'll get caught on that lever in there, that micro switch lever. So obviously you have to shove it in the bottom here and it sucks it through. It gets caught on this plastic roller on there, pulls it through and then over the head like that. Yeah, that's the way it goes. So some sort of, paper magnetic strip card storage, program storage thing. Probably held, 100, couple hundred bytes tops. Oh, thing of beauty is a joy forever. Look at that. That is beautiful. Look at all those end-on resistors with the white insulation over them. That's fantastic. Then we've got a bunch of op amps there by the looks of it, and this is all the head circuitry. So this is all the head driver and the head receiver for the magnetic drive there. So yep, that's all in its own separate shielded can, whereas all the bottom board down here is just all digital logic, and there's not much smarts in that at all, but that's gorgeous. I love that. And I do believe, take these two screws out here, this board is going to slide out from here. Yep. Yep. Look at that. Ah. Someone was thinking. Ooh. Oh no, I was going to say, is that a delay line? Looked remarkably like a delay line, but it will come out. Well, this has seen better days. Look at the... I'm not sure if you can see that. It's sort of like... Yeah, you can see the shine on that. It almost looks like it's conformally coated, but not all the way. It seems like like it's really patchy, like stops here. It's just... If it is conformal coat, look at patches in there. It's the worst I've ever seen. Or is it some sort of... I don't think it's like any sort of fluid contamination or something like that. I don't know. Is it like just... Like they didn't clean the board? It's got some old school flux cleaner residue on there or something like that? I don't know. Whew. And this layout's all hand taped too. None of that CAD rubbish. So as you can see, it's just 7.4 logic, and once again, none of the 7.4 LS or any sort of 7.4 HC rubbish or any... HC wasn't invented then. Yeah, just it's good old 7.4 series logic. So, yep. And bodges on there. Like, I don't understand that ground. Like, why can't that? Look, that's connected to there. Why can't... Like, did they actually leave it off here? Like, look, there's room for that trace to go around there and around to there. Did they... Oh, no, maybe not. Well, they could have then dropped it. Yeah, could have come through there like that, under that cap. So, like, what? Or that maybe they just had an issue with, you know, via current. Something like that. You know, they just wanted to lower impedance. Anyway, you can see that there's not that many bypass caps on there. They've got little jumper links, MC, whatever that means. And a couple of, you know, steering diodes and whatnot. But, yeah, not too many bypass caps. Don't need any of that rubbish. I love how the silk screen's under the chip. That's really handy, isn't it? And the backside of here is mostly, you know, 7.4 logic and that sort of jazz. It, oh, look. It's another slot there. Don't know what plugs into that one, because the other board just plugs into the top here. The tape drive thing, so, or card reader drive. So there's another socket down there, which is interesting. But once again, oh yeah, what's this thing? IC 6270. It's upside down, so all the electrons are going to fall out. Is that, you know, there's a whole bunch of diodes there. Do they go into it? I'm not entirely, got no idea. Anyway, this is interesting. Look at these Hitachi chips here. We got HN 35, 401, 402, 403, 404, and you expect it to go 405, but it doesn't here. It goes 405 is actually down here, 406, and then 409. So where's like 407, 408? Anyway, lots of blue bodge wires running everywhere, and we've got a little, is that a little, yeah, that's it, yeah, little transistor in there, and they've put a little, that looks almost like conductive foam on the back of that. What on earth? Little trimmer there. Don't know what they're doing there, but the main crystal down here, I don't know what frequency is that. Does it even have it written on there? Weird. And one thing you don't see here is your traditional EEPROM. You know, where's Wally? Where's the ROM? Obviously, this thing's the processor. These are all the same part number, so this has got to be RAM, but there's only there's 5 of them, so that's like an oddball number. This one here could be some sort of memory controller or something, but but why you'd need it for SRAM, I don't know. Anyway, and it looks like these are probably the ROMs, but once again, 2, 4, 6, 7. That doesn't make sense, really, and it's not that one, because that's not a sequential number along with them. So those in sequential number order kind of make sense from a like a ROM point of view. So they'd be like mask ROMs. All right, check this out. We actually have the service manual with full schematics for the SX300, and the only real difference I can find between the SX300 and the SX100, maybe apart from, you know, like a memory difference or something like that, is that the SX300 actually uses a magnetic tape system as opposed to the magnetic card system, and that's about it. But everything else seems identical. Check it out. We have a ton of stuff here. And here's a block diagram. We got the optional memory box, they call it. I guess it's a memory card. There's the control chip, which is that main one that I thought was the processor. It's not actually a processor as such, because this is not a microprocessor based system. This is like a multi-chip processor system, which is different. So it's got a control, so in effect they're making up a microprocessor with multiple chips. So we've got a control chip, a data chip, and an SR arithmetic chip here, and they're those three main chips that we saw, and I'll point out in a minute. We've got 6 different ROMs, and we'll go into the different ROMs. They're not all program ROMs. And then we have a printer controller, which has its own ROM. It's got a character generator ROM. Where we've got a display controller and gates and various other stuff. So there you go. Mag card amplifier, all that sort of stuff. I love the little wiring diagrams. Here's the keyboard circuit. So it's pretty basic matrix arrangement. Now I find this part really interesting. This is the auto clear and clear. You remember those 2 buttons on the top. They're actually like, I think they're wired outside the matrix and into this dedicated circuitry, which literally like hard resets stuff within the processor. So it's very serious business. It's not like the processor, it's not like the instructions in the processor read the matrix keyboard and, oh, you've pressed the clear key and it just clears it in memory. It resets the processor to a like a known state and stuff like that. They got diagrams and things like that, which is really cool. Crystal oscillator, 3.57 megahertz. Whether or not it's slower in the SX100, I don't know. And here it is. Here's the HD3541. That's that control chip. And once again, here is that HN35409, those 6 ROMs, or 7 was it, down the side there. This is ROM number 5. So these ones are the TWE and TD. These are like to keyboard. There you go. So that'd be, so this is a keyboard mapping ROM, so it doesn't actually contain processor instructions or anything like that. It's a mapping ROM. They do some old school mapping. Maybe I'm going to show you an old project I did. I'll make a mental note. I'll do a video showing you a an old school sort of like state machine compiler that I wrote back in the day using ROMs to execute instructions and programs. I might see if I can dig that one out of the archives. Remind me, pester me if I don't get around to it. And then once again, there's mention of the 3542. That's the data chip, so that was the one next to it. And it looks like the 3541, so what we thought was the processor, but actually the control chip, it actually handles the keyboard. But it's not a keyboard controller. It actually is a part of the microprocessor system, multi-chip processor system. Look at all the stuff they got in here. This is amazing. Wow, nobody does documentation like this anymore. It's great. So there are various flags, you know, processor flags and stuff like that. So, you know, it's implementing all this stuff, which you'd expect inside a microprocessor. It's doing this with these dedicated, these like separate chips, joining them together to form microprocessors. So there's the controller yet again, and it's got the memory box and interface. You see how that controller not only ties into the keyboard system, it ties into the memory box, memory and interface and the auto clear and instrument converter, inst converter, and ROM, and all sorts of stuff, and data transfer. So there's a separate data chip. It's not actually so it's just part of the processor. It's I don't know, you know, processor internal, what actual architecture this is, how many bits it is, all that sort of stuff, and what sort of architecture it'd be closest to. Is it like emulating old, you know, 8080 or 8008 or something like that? I don't know. Or is it its own thing? Who knows? And here's our ROM, the HM35401, 02, 03, and 04. So 4 of those ROMs are actually dedicated to the printer unit. So one is the character generator here, and it looks like the others are just like generate the data to control the printer and stuff like that. So once again, these aren't instruction-based ROMs. They're like hard-coded, like almost, you know, you could replicate these with PLDs and FPGAs and, you know, stuff like that. So it's using the ROM as a lookup table to generate, you know, waveforms and like not instructions, that's not the correct term, generate the required waveforms to drive the printer. Then you've got your other 4 ROMs here. 2 of them are display ROMs. One is a TW, that was the keyboard, wasn't it? TWE and timing type thing, and this was another one. And there's some of them are open drain, are they? Anyway, oh, lots of NAND gate. There's a display block diagram, cathode driver, and once again, these ROMs down here are controlling the actual segments going into the multi-channel 7-segment display. So they're in effect, they're like data to 7-segment decoder ROMs. So they're actually doing those in ROMs, which is really quite, you know, it's not a bad way to do it, because mask ROMs, I'm not going to say they were cheap, but they were, you know, simple and effective back then for doing stuff like this. So you didn't have to generate, in effect, they're using these mask ROMs as custom logic. Then we might have some sort of block diagram here. There you go. Mentally flip between those, and you can see, and there's the block diagram of the card driver. In this case, that'd be the read and write, that'd be the tape controller and stuff like that. So this would be different on the SX100, of course, because there's a card reader instead of a tape. Maybe it uses like the same system, except a physical tape they can just store more. Maybe that makes sense that they'd probably use the same protocol. So maybe all the, you know, a lot of the electronics are the same, maybe the tape and everything else, and it's just like motor drive and stuff like that that differs between the two. And then we've got our power supply circuit, and there's our standard, you know, there's our Darlington pass configuration like that. And we've got a Zener in there to +5, -7.5, +12, +9, -12, -6, -4. Jeez, needs a lot. Anyway, how cool is that? I love the diagram of the capacitor and the leads going off. That's great. Nobody makes manuals like this, and they give you the pinouts, little data sheet pinouts and stuff. Absolutely fantastic. Hats off. Someone went to a lot of more. Maybe it was one person put this manual together, and then they've got the the foil, you know, like, yeah, I'm going to follow that. Look at that. It's very arty, isn't it? That's terrific. Wow, that's great. And then exploded views, and that looks like a parts list. That's incredible. And for all you power supply aficionados, there you go. Don't you love the tubing? That's not even heat shrink, I don't think. That's just tubing. We've got our capacitors mounted down to the chassis, quite old school. It's a bit how you doing over here with the, what is that? The, you know, the series pass transistor for the linear regulator. They've got a heat shrink on there, but, you know, they're putting it down there, using it as a heat sink, and, well, there's not much else on there. Bunch of caps. That's a big ass inductor, or is it what on earth? No, it's a bridge rectifier. That's a big ass bridge rectifier. Look at that. Wow. Ha. AC's on the other side, 4-leg bridge rectifier with a hole in the middle, so you can like mount it on a chassis mount, and an arrow telling you where to shove it. Oh, Nippon Chemicon, fantastic. You think this is still going to work? Yeah, I think so. Oh, it gets a bit more interesting on the back. Check it out. There's a whole bunch of other pass transistors as well, with some little smaller trannies in front just to drive the base of those suckers. So, are they a little Darlington configuration perhaps? So, fused up here. Love our little connectors like that. Look at that. Beautiful. Look at that soldering onto the wires there. Beautiful, wrapped around. Thing of beauty. Look at that. Fantastic. And our transformer over here, made in Japan. All the best stuff's made in Japan. That's certainly a hunk of iron. Contributes to the weight, obviously. And then we've got our motherboard down in there, which is like, please excuse the crudity of the shot here, all sort of, you know, like a phenolic base type thing. It's not exactly a first-class board, that backplane there, but it doesn't have to do much. So there you have it. There's an aerial view of our Canon programmable calculator. Isn't it fantastic? Early, or in this case mid 70s, but this would have been designed in the very early 70s, I'm sure. And it's just got mysterious Hitachi processor in there, but coming in for landing on our camera there. No, I don't have any of that stabilizer rubbish turned on. Anyway, look at that. Oh, if you want to see, everything's made in Japan. There you go. There's your motor for all your motor fanboys. There's a closer look at the head. It's all gunked up. It's all potted. Couple of coaxes coming off there. Not much else doing. There's another look at the keyboard. Got our diode steering, of course, for our... It'll all be a matrix. And then we've got some physical switches up there. They've got cutouts in the board for those. There's our rotary selector for our decimal point indication, switch for our degrees, radians, gradients, and all that sort of stuff. And then our display up there, and the wiring for that. That's all pretty how you doing. Unbelievable. All right, let's see if this thing works. Let's power it up. 240. I've got some alligator clips on the back. She'll be right. No worries. Neutral. And phase. 240 volts, 50 hertz. Here we go. Whoa! Hey! Winner! Check it out. You can hardly see it. Geez, that's a tiny little 7-segment LED display. Look at that. But it looks like... Ha! It works! Winner, winner, chicken dinner. And check it out. It still prints. What? Let's do a paper... Do a paper feed? Print. Oh, check that out. 13 decimal places. That's pretty impressive. Whoop. I've got printer off. Thank you. So that's pretty impressive. We've got 16-digit mantissa, 3-digit exponent. Wow. This thing was kicking some serious ass. All right, so let's clear that. Let's do the old... Oh. Whoa. Okay, bit sticky. Let's do the old 69 factorial, shall we? We've got a dedicated factorial key, which is, you know, it's a bit how you doing. Oh, it printed the... Oh, you see how it sequentially came up with that? Our printer's going haywire. What? Uh-oh. It's one sick puppy. Okay, I repowered it. I think it got past the... out of the jam over to the end stop there, so maybe it'll do something now. So let's try our 69 factorial again, shall we? There we go. That's pretty quick. All right, so let's try the famous calculator forensics. So what I'm going to do is 9 sine, cosine, tangent, arctangent, arccosine, arcsine. There we go. There's our calculator forensics result. For those playing along at home, not bang on 9, 8.99999 86441800, and I'm sure that doesn't match. And well, it'd be interesting. I'll look up the database of that and see if it matches. But of course, it's not going to probably. Who knows? It might use the same algorithm as some other calculator chipset or something like that. But this one, anyway, and that's full floating point mode, of course. What if we haven't actually tried this? What if we change that on the fly? Nah, doesn't do anything. But if we did that on the fly, let's say we had 6 decimal places. Try it again. 9 sine, cosine, tangent, arc, cosine, arc, sine. There we go. And, well, that's supposed to be 6. Okay, so that doesn't work. All right, I know you want to see me run a program, so let's do it. It's actually not too bad at all. OPE is operation mode. So, you know, this is like 1 + 2 equals. There we go. And it's going to print it out. 1 + 2. There we go. It actually prints it out. But if you want to record a program, you put it into learn mode like this. Okay, we'll clear all like that. Now, this is, you can actually store multiple programs on here. So SPNN key here, it means store program NN. So you've got to give it a hex number. So we'll store program, and it says unfinished here. So we actually have to tell it 0, 0. Okay, so we're now inside so we're storing a program. Now we can do our sequence. So if we go 1 + 2 + 3 equals, printed all that stuff out, and then we just go end program like this, 0, 0, and we're good to go. So we've stored our program now, and we can go back to operation mode like this, and we just press start, and it'll run our program. It just executed our program and gave us, well, it gave us our answer here. Fantastic. So it's given that, and it's displayed. Oh, you can't see it. It's not very good. The printer's not great, but it has actually printed out that, and it was printing out our program as we were going, because we had the, you can turn the printer key off here if you don't want it to do that. But there you go. That's pretty neat, huh? Let's try program print. I haven't read the manual on that, but I assume if we press that, yeah, 1 + 2 + 3 +, there it is. That's our program that we entered in. Fantastic. And you can store multiple programs, and you can like go into debug mode. You can check mode, which allows you to go in and edit and all that sort of jazz. And I assume load and record. So if we shoved our card in there, we could record our program to magnetic card, I guess. So that's pretty groovy, isn't it? I actually like that. It's actually, you know, it's fairly well thought out. It's fairly simplistic once you know. I mean, you can't, like, obviously just walking up to it and trying to use it. But once you spend just a few minutes reading the manual and you go, yeah, that's, that's pretty obvious. Of course, you can go in there, if you want to edit your thing, you can go to particular lines and do edits and inserts and, all sorts of stuff. So you can modify your program. And, of course, you can do go-tos, go to various steps. Looks like you can set flags and things like that, column prints and line feeds. It's obviously fix, does that fix the number of your decimal places or whatever? But anyway, you can do various, programmatic functions like that. So that's not too jazzy. I'm kind of liking this thing. It's really good, and it works. Works a treat. Still trying to figure out why, if you go clear all and then see, it gives a couple of ones, a 1 there and a something over here. Yeah, I don't know. Not sure. Anyway, that's a fascinating example of 1970s calculator technology. Hands up if you used one of these or an older model or something like that. But anyway, I hope you found that interesting. If you did, give it a big thumbs up. And as always, you can discuss down below. Catch you next time.